Okay, here's question 26. Let's just straighten this question a bit. Okay, question 26 is the last paper on the higher non-calculator paper. It says the graph of y is equal to f of x is shown on each of the grids. So there's this part A and there's a part B on the next page. On the grid, sketch the graph of y is equal to f of x minus 3, and the x minus 3 is inside the brackets. Now, this is one of the facts that you really just do need to know. If it's x minus 3 and that's inside the bracket, the graph is going to move horizontally. Right? Which way does it move? Does it move towards the left or does it move towards the right? Well, one of the things about this, in terms of remembering this, whenever I teach this, I always say that it's the opposite way to which you think it should go. So you think if it's going in the minus direction, it's going leftwards, but it's not, it's going to go rightwards. And there are a couple of ways in which you could do this in order to make sure you get everything going for it. So I am inclined to trace the graph or just get a couple of key points, and there's my graph there. And if I do move it, how many? Minus 3. So minus 3 means I need to go in the positive direction. 1, 2, and 3. So a couple of key points here. Just want to make sure that it lines up with certain points. It needs to line up with that point there, right? And here you go. And I'll trace over this on the sheet again afterwards, but I want to make sure that I'm going to get full marks on this. I don't really want to slip up. Okay, so there's my solution, and a lot of it is on the graph. So just take your time, draw it, trace it through. A lot of people do have difficulty with this, not only getting where the graph should go, drawing the curve as well, and that there is enough for me to get full marks in this. 2 pretty forward marks. Because it's f of x minus 3, it's going to go 3 units in the rightwards direction. Okay, here we go with part B. And part B is a bit trickier, not loads, but on the grid, sketch the graph of y is equal to 2 f of x. Now, f of x are these values here, the y values, and 2 f of x means we're timesing them by 2. So what I suggest we do is we find a couple of nice points, and what I mean by that is where, like there, that coordinate there is 1 minus 1. So it's nice whole numbers. That coordinate there, it's 3, 3. That coordinate there is minus 1, 3. Okay, so I've picked 3 points, right? And that's okay. Actually, I could pick 2 more over there. That's 0, 0. I could pick that one there. That's 2, 0. So for each of those, right? So for each of those, the y value 3, I'm just going to times it by 2 to find out where this transformation should end up. Right, so if I times 3, that's the y value. So this is my f of x right now. Its y value at that point there is 3. But when I do the transformation, I'm going to times that by 3, so that will end up there. This one here, the y value is 0. So when I times it by 2, it's going to stay put. Go across there. This one here, the y value is minus 1, so times it by 2. Should say f of x actually, that might make it clearer. So f of x is minus 1, f of x, 2 times f of x is going to be minus 2. Over here, f of x is 0, times it by 2 is still 0. Over here, f of x is 3, times it by 2 takes me there. Now all I need to do is to join up all of those points with a nice neat curve, and I'm actually going to have to remove this because I find it easier to do it this way, and I can see a mistake. I shouldn't have put crosses there. Those were just the points I began with. And so what I'm going to do is draw a curve through there, down to the bottom. We'll do light to begin with. I've got that. And then the other side. Okay, there you've got it. You've got your full curve, and there's your answer. All right, it's a stretch, a vertical stretch. Right, you times f of x in the original curve by 2 to get all the new points. Okay, this is a straightforward question when you know how. Make sure you know how, study it, and make sure you can do it.